All right, we are now working on definite integral using geometry. We'll not be able to evaluate every single integral using geometry, but if the shape under the curve is a perfect geometrical figure, then we'll be able to use geometry to evaluate that area. For example, the first one, we have to find the value of this definite integral from 1 through 3 of 3x plus 2. So what we're going to do first is we are going to draw a diagram to represent the function 3x plus 2. So let's first draw the x and y axis and draw that function. Suppose that is my y-axis. This is my x-axis. Now I need that function. The function is 3x plus 2. So the y-intercept is 2 and slope is 3. That means you can start at 2 and then go up. So that will be the function. You can represent like that. Or if you don't want to represent by the line and you want to do it just by the line segment, hold on, something is not working here. That is my x-axis. I was about to draw the function using the green. That is my function. So that function is f of x equal to 3x plus 2. We need to evaluate the definite integral from 1 up to 3. The definite integral is same as area under the curve from x equal to 1 to x equal to 3. So when x is equal to 1, x equal to 1 is here. That is x equal to 1. And x equal to 3 is maybe here. This is x equal to 3. We want to find this definite integral. This definite integral will be equal to the area over here. It will be equal to that area. And if you look at the shape of this area, this is a trapezoid. This is the trapezoid. And you know how to find the area of trapezoid. Using geometry, the formula to find the area of trapezoid is area equal to half times the height plus base 1 plus base 2, half times height times the sum of the base. So in this case, when I say the height, this distance is the height from here up to here. That is the height. So if I want to rewrite this, it will be half multiplied to the height is this distance between the parallel line. These two are parallel lines. So that height will be 3 minus 1, which is 2. And then times the base 1 plus base 2. So this is your base 1, B1 plus B2. So when I say this height, B1, it's the value of the function at 1. So if I plug in 1 to the function, it will be 3 times 1, 3. 3 plus 2 is 5. So this height is 5. So that is 5. Plus this height now, this one is the height at 3. And you plug in 3, 3 times 3, 9, 9 plus 2, 11. This is 11. So area is equal to half multiplied to 2 is 1. 1 times 5 plus 11. 5 plus 11 is 16, which is equal to 16. So the value of this definite integral, which is from 1 through 3 of 3x plus 2, is equal to 16. It is easy to evaluate because this region here is a trapezoid, and we know the formula to find the area of trapezoid. So here we use the geometrical formula to find the exact value of the definite integral. If you use the limit of the Riemann sum, it's going to be a lengthy math, but you'll get the same result, 16. You can try the limit of the Riemann sum to evaluate this integral. You'll get the same result, but using geometry is easy. Using geometry is not always possible. It is possible here just because the area over here is in the shape of a trapezoid. So in part B, we have to evaluate the definite integral from 2 through 3 of the square root of 1 minus the quantity x minus 3 quantity squared. So if you try to sketch the graph of square root of 1 minus x minus 3 quantity squared, it will be the upper half of the circle. It will be a semicircle. Although I have shown a complete circle here, this one is only the positive part, so it will give you the upper half of the circle. And then we are supposed to integrate from 2 up to 3. So 2 is here, 3 is at the center. So we are integrating from x equal to 2 up to x equal to 3. That will be a quarter circle. So meaning of that is the value of this definite integral will be 1/4 of the area of this circle. So that area represents the value of the definite integral. And we know that the area of circle is pi multiplied to r squared. But here we are talking about 1/4 of that. So pi r squared over 4. Pi multiplied to, here the radius is the distance from this point 2 comma 0 up to 3 comma 0. That is the radius of 1 squared over 4. So that means the value of the definite integral is equal to pi divided by 4. So we are able to use the geometry easily and evaluate that definite integral. It is not that easy to evaluate the definite integral given here without using geometry. So some problems are easy to integrate by using geometry, whereas some are not that easy to evaluate using geometry. We can use geometry to evaluate the definite integral if the shape is a regular shape, a familiar shape that we know, and we have a formula in geometry to evaluate that area. So that is about the evaluation of definite integral using geometry.